A team at the University of Otago has unlocked some secrets to do with the development of cancer. Dr. Peter Mace of the Department of Biochemistry has led the research and he's here to tell us all about it. Good evening.
Good evening.
Peter, what has this study been about?
So we've been looking at proteins called tribbles. So tribbles, they were named after a small creature that comes from the Star Trek TV series actually. So some researchers in flies found that if flies have the wrong level of tribbles proteins, the cells proliferate kind of uncontrollably. And so we see the same effect in blood cells. If they have too much tribbles, then the cells proliferate and you can get a disease like leukemia.
How did you discover this?
So our research uses a technique called X-ray crystallography. So what we do is we try and make a really pure sample of tribbles in the lab, and then we incubate it with hundreds of different chemical solutions. And if we get the balance just right, we can grow small crystals of the protein, which we then shoot with a powerful X-ray beam, and from that we can work out the exact 3D structure of the protein.
Well, it certainly sounds like something you would see on Star Trek.
Yeah.
How long does that process take?
So crystals, they can grow in a few hours or they can grow in months. So the project's been kind of ongoing on and off for about 2 years so far. Yeah.
How could this information be applied?
So this is an important first step towards being able to treat tribbles and cancers once we have the 3D structure. It's kind of like a 3D map, which we can start to think about how we might be able to fit small molecules that bind to tribbles and block it from having its function. So it's kind of like a locksmith fitting a key in a lock that we would like to do down the track.
What is the biggest challenge in studying these proteins?
So up till now, the challenge is always when you have those hundreds of chemical conditions, getting the balance just right to get this protein to grow crystals. And then I guess the next challenge is going to be in something like a cell where there's thousands of proteins around it, finding out how tribbles behaves then. Yeah.
Have you got more funding to further this research?
Yes, so just excitingly earlier this year with Anita Dunbeer, also at the university here, we received a Health Research Council grant to carry on with the research, specifically looking at tribbles and breast cancer in this case. Yeah.
So what is the next step?
So I guess there's two branches to it. We're going to look in breast cancer to see if tribbles is doing the same thing that it does when it goes awry in leukemia, but also we're going to try to screen compounds that can bind to tribbles to make the first steps towards actually being able to create treatments based on tribbles.
Yes, what is the specific goal here?
I guess it's twofold. We would like to make small molecules in the long run that can bind to tribbles, but also the more we know about how tribbles functions, then we might be able to use existing drugs that actually are more effective in cells that have more tribbles proteins.
How many people are working on this project?
So on this project here, it's been a pretty small, just a couple of people up till now, but this Health Research Council funding is going to allow us to have about 5 people in Dunedin. And we've also been collaborating with a team at the Walter and Eliza Hall Institute in Melbourne as well.
And when do you hope to have some more findings?
I guess there's various findings all along the way. So straight away we put our 3D structure that we calculate, we put it on the internet that's publicly accessible to all researchers who are looking at tribbles around the world. In a few years, hopefully we'll know more about what tribbles is doing in breast cancer, and then the long term, as I said, the long term goal is to be able to actually treat tribbles directly.
Dr. Peter Mace from the Department of Biochemistry, thank you very much for your time.
Thank you.